So for all the remaining lessons within this unit, we will need our calculators. So we're first going to start with this function. We're going to solve for x. So we have 3 to the x equals 7. So the first question I have for you is, what form is this in? And since we see an exponent, a variable in that exponent, I would call this exponential form. And the variable is located in this exponent. So let's translate this to log function, to log form. So if we have our exponent, x equals the log base 3 of 7, then we can plug all of this into our calculator and find out what the log base 3 of 7 is. So how do we do this in our calculator? If we hit the math button, okay, the math button, and then hit the arrow up, notice how it says log base parentheses. That's what we're going to select. And then look, we can input the base. So I'm going to input the base of 3 of 7, log base 3 of 7, and I get 1.77. And I'm going to round to the nearest hundredth. So on my notes, I'm going to say x is 1.77, and that is our answer. Okay. So if this equation was 3 to the x equals 9, we automatically know that that is 2. But sometimes exponents will not be exact whole numbers, and we're going to have to use logarithms to help find out what those exponents equal. Okay, let's go to the next example. So what form is this written in? I'm going to give you a hint. If you see the word log in the equation, in the original equation, it is in log form. So we have a log base 4 of x minus 2 equals 2. And the variable that we're trying to solve for is in that logarithm. So a way to get rid of that log is to rewrite it in exponential form. So I have 4 to the second power equals x minus 2. And this one I can solve. And I can solve without using my calculator because it's actually quite nice. So we get x equals 18. Okay. So here's the strategy we have to use. We have to ask ourselves what form the problem is in and where is the unknown. So if the unknown is in the logarithm, it's a log form. If the unknown is in the exponent, it's an exponential form. And if it's in exponential form, we have to translate into log form. And if in log form, we have to translate into exponential form. And then with the calculator, as long as we practice this throughout this lesson, I think you'll be able to get it. But you hit the math button, hit the up arrow, and then you have to find log base. Okay, so let's look at this one. Where is the unknown? Is this in log form or exponential form? This is an exponential form. So we have to solve for x. And the same way that we've been isolating variables, we can use the same strategies. We want to isolate the term that has the variable. So I'm going to begin by subtracting 7. So I have 4 to the x plus 3 equals 8. Okay. And now that I have 4 to the x plus 3 equals 8, the only way for me to solve for that variable is to rewrite into log form. So to rewrite into log form, I have my exponent equals log, since my base is 4, log base 4 of 8. And then finally, to solve for x, I have to subtract 3. But I want you to be mindful that you're subtracting 3 from the log base 4 of 8. So in our calculator, we hit the math button, up arrow to log base, and the log base 4 of 8. And then outside those parentheses, I can say minus 3. And I get negative 1.5. Okay. All right, let's look at the next one. Okay, so is this in log form or exponential form? If you see the word log, it's in log form. But a way for us to write in exponential form, if we go back to our previous log problem, we had a single logarithm equal to a number. So how can I make this a single logarithm on the left side? Well, we can use our properties of logarithms. Since we're adding logs of the same base, we can rewrite as a single logarithm by multiplying x times x minus 1. So the log base 2 of x squared minus x equals 1. Okay, so these are log properties that you're using from the first step to the second step. Now this is in log form. We have a single log equal to a number. So if I rewrite this as 2 to the first equals x squared minus x, now I can solve and say x squared minus x minus 2 using the zero product property, and I got x is 2 and x is negative 1. Okay, but can x equal negative 1? Can we have a log base 2 of negative 1? No. So we have to reject that and just accept the x equals 2. So there may be problems that you don't need the calculator for, but we still need to know how to use the calculator. Okay, so let's recall the one-to-one properties of exponents. All right. I had 3 to the 2x plus 1, and then I have 9 to the 4x. So the one-to-one property, if we have exponents and on both sides of the equation, and notice how we have a variable on both sides, we have to rewrite the bases. So 3 to the 8x equals 3 to the 2x plus 1. And then since our bases are the same, we can set the exponents equal. So 1 equals 6x, and x is 1/6. Okay, so that was from last week. This is the one-to-one property of exponents. So since we have a one-to-one property of exponents, we also have a one-to-one property of logarithms, meaning we have a single logarithm of the same base written on the same side. So a logarithm equal to a logarithm, and they need the same base. Okay, so if this is something that the problem is giving you, then we could just set these values equal to each other. Factor. And I got 4 and negative 1. But we have to reject that negative 1 and accept the 4 because we can't take the logarithm of a negative number. So here's a one-to-one property of logs. If we have a single logarithm, so one logarithm on one side set equal to one logarithm on the other side, and it has the same base, so log base b of x equals log base b of y, then we could say x equals y and solve. Okay, so let's look at this one. This is in log form, but notice how we have a log on both sides of the equation. Okay, log on both sides of the equation. So we're going to use our properties of logarithms to rewrite the left side as a single logarithm. So I'm going to move my 2 to the exponent, and since we're adding, this is log base 3 of 5x squared equals log base 3 of 14x plus 3. So since we have a log base 3 and a log base 3 on each side, we can use that one-to-one property. And we can use the zero product property to solve, possibly. Okay. So I have 5x and 3. So we have negative 15 plus 1. So x is negative 1/5 over here, or 3. But can x equal negative 1/5? So let's go back to the problem. And when you go back to the original problem, notice how this x is by itself, and we can't take the log base 3 of a negative number, so we'll reject this and accept that answer.